Hi, how are you, everyone? Um, I just add this to the comments. Please don't forget to check in to the event uh, with your MLH account. In this session, as we saw last Wednesday, I think it was, yeah, we're going to split an image in every single element. So we're going to recognize the patterns to get the letter from text. So why are we doing this? Because in further editions, we're going to use this same code to train a neural network to predict text, but also to extract text from images. This is cool, right? Don't forget how we started in our previous sessions. We were detecting borders in images. We were learning about color segmentation. We were learning about um, how images are data and how we can manipulate that data to do whatever we want with the images, expand it, slice it, and make another image, rotate it, whatever we want, right? So we have a question here. What software and IDEs are you using? Um, Myself, I'm using Matlab because Matlab has some very cool built-in tools we can use to do these artificial vision techniques, but you can use whatever language IDE or tools do you want. Another recommendation could be Python in NumPy and Pandas. It's also a great tool to do computer vision. Um, but yeah, if you do JavaScript, you are not excluded for this. You can do visual recognition with JavaScript. To be honest, there's no problem with any other languages. The only reason, again, I'm using MATLAB and I'm repeating this every session, it's because I have my codes there, and it has some features built in that doesn't need me to install more packages or whatever. Remember, MATLAB, it's kind of different from other languages because it's not zero index language. Its index it starts at one, so the first element in our arrays or whatever has index one. But that's that's kind of weird, but it's something you get used to. So I see we have many people here. Did you join us for the last sessions, or this is your first time in the image processing workshops? Uh, I want to know where are you from, or your background, so leave it in the comments, please. Then I will start showing my screen in 1 minute, so we can give time to people to join us. Uh, Hello. Remember, if you do the same as I'm doing here with any other language or even with MATLAB too, you're welcome to share your code. You can, I think you can join the stream, or even you can share via GitHub or whatever other code repository you're using. So let's open MATLAB. I'm not sharing my screen yet. I'm just preparing everything. Okay, I'm going to start to share my screen now. Please let me know when you see my screen. I think you were supposed to see it now. I'm going to open a new script here. And recommendation here is you can type Matlab or MATLAB or MathWorks, whatever you want. Uh, this is the MathWorks page and the Matlab Academy. So you can do these cool free courses when you can learn more about how to do computer vision, or for example, I just finished this one, deep learning with MATLAB. It's really cool. There are free and they are very complete. To be honest, you will learn a lot, and you won't regret the time you spend here. There are any levels from beginners. For example, it's like a MATLAB on ramp. It's only 2 hours long, and you can go further as you want. Hey, we have this one here. Hello. So this is the file, but what are we going to do here? I give you the spoiler the last time. For those one who miss it, you will have to wait to the end of this session to see it working. But don't worry, I will go and explain everything here. Let's do the basic, that it's set up our environment. We need to clear our command window, clear our workspace, and close or figures or whatever prompts we're using. If you're using the web environment as me, you probably won't need this. And if you're using the NLX or the live script files, you probably won't use it. But again, it's a good practice. It's just one line of code. It doesn't matter. What we need to do next is to import our image. Remember, we can call it ima, and we can do an ingrid. And I'm going to copy the path here. Oh, it's just a name. And we are going to display the image with imshow. Let's see what we have. Our image is text showing the entire alphabet. Uh, Here it is: A, B, C, D, E, F, G, etc., etc. So let's think about how we get every single letter in this image. The first thing we know is the background. It's white, and we don't want to process a big amount of data. We can translate this otherwise and making the background black and our letters white, because remember, every value in an RGB image has to be from 0, in this case from 1, to 255, 256. And the combination of all colors, it's the white. That means 255 will be the white, and zeros will be the black. And in our image, we have a lot of non-zero values. To make these more like zero values, we can do this simple command. Um, copy and paste this. Oh, we have a problem here. Oh, yeah. The thing is, we have to translate it first to gray. Because here we have a three layer matrix, and first we need to turn IMA into RGB to gray IMA. That's right. Then, to make sure our values are non-zero and non-negative values, we can turn IMA into double. And to save space here, we can delete this. And 127, it's just an idea. You can play with these values. For example, you can see here I'm using 200 to make it more clear. But let's see that in practice. As you saw, our image, it's like if we invert the colors. Now our background, it's black and our letters are white. If you do a little close-up, you will see some information it's lost. That's why you can play with these values. So for example, if you do 200 and run this code, we probably get a sharp image where the borders are not that have not that loss of information. So I do the test and this value works fine for my image. But if you are using another image, you can move this parameter. So the image you get, you will be sharper or it will get blurry. That's the parameter you have to move if you see your image it's getting blurry or it has enough sharp. Then what we need to do, we need to go from the first line to the second line and extract every single letter. Why first with the rows and not the columns? We have two rows and we don't know how many columns. It's supposed to be one, two, three, I don't know, as many letters we have. But we're doing this again because we have only two rows. But if your image is displayed in a way that you have better comprehension of the shapes in column wise, feel free to do it column wise instead of row wise first. So we need to set two variables, right? FSR will be an empty array, and FVR, it's VR, right? Yeah. Again, it's an empty array. And we iterate for E starting in 0, in 1, till the length of SF. Oh, I saw here that it's starting with 2, and I'm going to explain why, but just give me a minute. SF, oh, I get it. Let me explain this line of code. And remember, in MATLAB, when you put semicolons, you won't see the output, but when you take out the semicolons, you will see the output. I am going to run this, and with the result, I'm going to explain why are we doing this. This is okay. See one thing, and I need another thing that it's plot FF. Okay, you can appreciate this, right? What are we doing with sum? I'm going to pass this to the right side. Remember, in our command window, we can always type help and the command we want to get information about. This time is sum. Sum, you can, it's it's silly because it's the sum of the elements, yes. But when you get only one parameter, it's the sum of every element in the vector. But if it's a matrix, it's a row vector with the sum of every column. Now, when you put a second parameter here in sum, which in this case is 2, you're telling the sum operation that you don't want it to be uh, for each column. You want it to be for each row. So if we change this to 1, change it to 1 will be the same as just not putting anything, but let's make it explicit, right? Let's change it to 1. And you see how we have now columns. And if we put 2, we have the rows. This is cool. And I want you to imagine something. See the original image. Remember, in this case, if I put 1, we're getting the information. Oh, it's not displaying the original image. Come on, here it is. Sometimes MATLAB it's a little slow, but give it a chance. You can see it's not perfect, but we kind of have lines where we have yeah, where we have the letters, right? And if I've changed it to row wise, we kind of have blue lines when we have the the rows. One with the row starts and one with the row ends. Same here, one with the row starts and one with the row ends. That's why we have 4. So in this little section of code, we are getting the information about when a row start and a row end. We are getting every single value in IMA, and we're summing it row-wise. That's what the 2 means. So let's split this little section here. I'm just going to put S, and S is the sum of IMA row-wise, and I'm going to plot that just to see what the next part does, which is compare it to a 1. If we plot this without comparing it to a 1, we got noise. I mean, it's not a true value because yes, maybe the sorry, it's wider than the B or the C or any other letter we have here. And it starts earlier than the I mean, the capital A starts first than the small e. So that's why we have this peak here, and the other peak is a little bit lower in the value. I mean, this is fine, but this is not what we want. What we want is just an indicator of where the row starts and where it ends. So we can turn this into a 30 value, just comparing it to 0. Here, it's bigger than 1. Oh, here, it's bigger than 1. No, then 0. It's bigger than 1. No, then 0, then 0, then 0. Here it is. So give me give me a complete one. What will we have here? In this case the same, and in this case the same. You see, 0 0 0, we have. Now don't we have 0 0 0, we have. Now don't we have. That's why we are comparing this result with one, and just to make sure everything's fine, we translate it into a double value with it's the type of values in MATLAB. Don't worry about it. So now this is explained. I am going to explain what we are going to do here. We have our rows separated. Well, no, but we have the information to now separate them. Uh, if we compare, for example, in this case, we have 0, then 1, then 0, then 1, and then again 0. When we change these values, we have to compare the previous value and the next value. If the previous value is 0 and the next is 1, that means the row is starting. If the previous value is 1 and the next value is 0, that means the row is ending. And when we have that information, we can store the data between those changes as a row. That makes sense, right? And that's what are we going to do in this code. First, for all the information here, which is displayed here, we start going this value, the previous value, it's 0, and the next value, it's 0. So we don't do nothing. And we go on, 100 values, 180 approximately, I don't know. And when we get to this point, we said previous value 0, next value 1. Okay, perfect. We have a change here. So we're storing that value in this vector. Remember, an array, it's a vector. When you think about it in mathematics more than in program, a vector it's an array basically, because if you have an array of n dimensions, then you have a matrix, and when you have an array of n dimensions, more layers inside that object, you have a tensor, and etc etc etc. So we end this code here. We go here and make a copy of this. And remember, what we need to do is compare the previous value, in this case 2, and the next value to see if it's a change, if the row is starting or it is ending. So if it is starting, we save it at FSR. And if it is ending, we save it at BFBR. Let's show what does this mean? We can get this. I'm right. Yes, there. Uh, you wanted you are going to transpose the vector. So if you have a column, you get a row, and it same the other way. If you have a row with this, you get the column. Um, this is to explain it more easily. We can run the code, check for no problems. And what we have here is a 2 times 2 matrix. This is a matrix. This is how do you define a matrix. If I run this separated, again, just this one, and I could get two different vectors. But I want to create a matrix. That's why I'm putting this together, but also I'm changing the orientation of the vectors in the matrix. What does this mean? It means we have a row here starting at 161 value, approximately this one, and ending in 182 value, this one. And the other row starting at 215 and ending at 240. It is this one. If we have more values, if we had more more rows, sorry, we will have a third column here. If we have four rows, we will have a fourth row here. So that's why I'm changing the orientation. So each row here means a row in the real image. Okay, that's perfect. Now we have the information about these little rows. The next thing we need to do is, oh, sorry, I need to change this. I'm going to take advantage of this and just answer some questions. I have this one. Hello, what is today's session program then? What project are you going to do? Can you give us an idea? Okay, yeah, I talked this about in the beginning of the session, but I can repeat it. We're building a program that splits every single letter from an image. So in further editions, we can use this same program to make to get text from images. Why else are we doing this? We are putting in practice what we learned this far in the past sessions about how to manipulate images. For example, in the past one on Wednesday, we get the borders from any image, more complex images, a real picture. For my camera, for example, now we're starting again with some more easily that it's oh my god, I think I lost connection for a second. Okay, I think we're back. Sorry for that. Um, I was explaining what are we doing. Yeah, we're using an image with text, with simple text, so we can recognize the patterns in an image and separate it from the original image in slices, and then interpret what is in these slices, right? So in the example of this class, we're getting letters, and we're going to get every single letter of the alphabet. So that's the project of this class. And we have another one. Hello, can you please share the link in the discussion window? Sorry, the link of what? I'm not doing a collab or something like that. I could share the code at the end if you want. Um, yeah, I think that could be possible. So, returning to the code, we were saying that now that we have our rows separated or information, and we know they start at 161 and 182 and 100 and end, sorry, at these values. What we need to do is take the information of this row and do the same as we are doing here with the sum, but this time not row wise, this time color wise, because I'm going to, yeah, a little soon. We went column wise first because it was easy to get information without noise. There's no other thing here that we can uh, that interrupt our flow. But now that we have our role separated as an individual element, we now go column wise to get the A, the B, the C, the D, the E, the F, etc. So how we do it again is this part of the code. We need to copy and paste this, and then we can explain. For every element in the first row, FBR, remember, this part, we will get, I'm going to change this in English, row. We will get, we have to go for every value, in this case, just two values, and save it into a cell array. Cell array are a type of a type in Matlab that allows to save elements like it will be, I don't know, lists in Python. It's just a type in Matlab. Just trust me, and this is the syntax. And we store the first value of IMA and the first value of this means from this point, I mean FSR, where the row starts, to FBR, where the row ends for every layer, right? So we store a little r, doubling the row information, and this is where we're talking about. We now go column wise to get the information from every letter. So we can call this letter. And I have two little variables here just to help with the loops. And the length of the letter is if letter in the second position it's 1. I mean, again, it's the same principle. If the change of values are from 0 to 1, that means the letter is starting, and we store the value in FSC. And if in the letter value, oh, typo, if the letter value was 0 to 1, that from sorry, from 1 to 0, that means the letter is ending, and we store the value in FBC. Uh, these ones are for helping indexing. So we can now go and for the next part of the code, this is just to display the images. For the size of FVR, yep, which is where the rows were ending, we go and get the information from 1 to 26. Why 26? Well, 1, 2, 3, 4, 5, 6, 7. Because we have 26 letters. We can do this a little bit programmatically. We can use length, but don't worry. In this case, we have 26 letters, so we just need to go 26 iterations of this. Uh, so that's no problem. We get the size of ring long, and we just need to adjust some things here in the code. Oh, let me just comment this and show you the values of FSC and FBC. Let's run this. You see, we have 26 values times 2. Why is that? We have 2 rows and we have 26 letters in each row. So, little recap. I hope everybody understand until this point, but I get the sensation I don't explain that well this little part here. So I'm going to explain it again. Sorry. For the length of the rows, this is programmatically speaking, but we can use 2 here because we know we have only 2 rows. Well, for the length of that, we need to store in a value called row the position of the image in between where it starts and where it ends. That means all the row values between those positions, and as the second, like here's the comma, the second parameter here, this means all information in columns. So store between where the image starts and where the image ends, all the column information in a cell array called row with index 1 at the beginning, but in the second iteration it will be 2, etc. And we store a letter information as we had stored before the row information. No, sorry, this won't be letter exactly, but don't worry. It store all the information of where you get the sum of row column wise. So that's the same we were doing here, but instead of row wise, column wise. And in this case, we will have 26 times 2, which is 52 values, lines. If we plot here, we'll have a plot of, we can do that. Just give me a second and you will see. So I don't want to count them, but trust me, there are 52 lines here, meaning the first line, here it starts, and here it ends the letter. Then here it starts, and then here it ends the letter. Then here it starts, and then here it ends the letter. So that's the process. We can get rid of this. And same for, we have to compare. That's why we're starting in the second position, was because we want to compare the current value and the previous value. If the current value is 0 and the previous value is 0, there is no change. If the current value is 1 and the second value is 1, there is no change. If the current value is 0 and the past value is 1, then that means the program, the letter is starting. If the current value is 0 and the previous value was 1, that means the letter is ending. So we store those information in these variables called FC and FBC. So that was the same as we were doing here. You remember it? Everything's okay. But why the O1 and O2? Well, O1 means for the first row, and O2 means for the second row, right? No, sorry. The J means for the first row because it's the first iteration, and the O just means the amount of letters starting with 1. We have one letter starting and one letter ending. If you see, we have the 26 values here. So that means in the FSC parameter, we're storing in the first, when we run this program, the first time this will be 1, and we store a value of 421. The second time it increments, and we store in the second position a value, but again for the first row, a value of 255. That's what this code means. And again, now we have the meaning of this data. If we just saw this as information, there's no explanation. It's a little confusing, but with this graphical help, now you understand that every change in the value of these ones means that there is a letter in that position. So now we can display all the data here. We can erase this, and for the length of the columns, remember we can change this 26 for length of FCS. Just let me do a little thing here. Oh, I mistyped FCC. Again, I'm going just to comment this to know it's poly. I just want to make sure this is 26. Give me a second. Yeah, it's not length possible because these are matrices, so it's not a vector. We need to use size, and size give us the rows and columns. And in this case, we need to use the columns. So C, it has to be 26. Perfect. Uh, Now we can uncomment this and we can put C, and that will be the same as 26 in this example. Again, if we want them to run the code with any other image, this will be better because we didn't have to change the parameter. So better practice. And we store in an X variable. That X will mean the in this case now the letter, but before we will need to change all of this. Uh, yeah, this will be in the letter, but for not changing the code, let's leave it that way. And again, remember from IMA, we want to get the information of the row from where it starts to where it ends. And now we doesn't want every single aspect of the columns. Now we want specifically from where it starts and from where it ends. And these, as you can see, have two different parameters. The first one is the row, and the second is the column. In this, for the first row, and when we repeat it again, it will be for the second row. We can do the exercise again of displaying F, B, C, and F, S, C to make it more clear. But when we slice, and that's what are we doing here, we're slicing the specific zone in the image from getting X, and X will be the the letter. And then we do this 26 times 26 because we are giving a space of 26 from 26 for every single letter. We can comment this, but we are going to see that some letters are bigger than others. So this space they use, it's different. Some will be 23 times 12, I don't know, the L, for example, or the M will be smaller or wider, will be 12 times 28. I don't know. No, 28, no, because I proved it before and the bigger ones are like 26. 26. Why? That's why I put this. But let's run it without it, and you can see the difference. So I think we're ready to run our program. Yeah, let's see. And I want you, okay. Oh yeah, this is row. Sorry about it. And then we are ready to run it. You see A. Oh, B, yeah, it is. GHELMO. You see how this is running and how letters have different sizes, right? I want you to keep in mind that. For example, again, C, the E, the I, sorry. This is like 1, 2, 3, 4, 6 pixels. And this is like the 26 pixels we wanted. So to standardize that, we do this little section of code, and we can run this again, and we will see all the images have the same space. It's running low. Sorry, Matlab. Yeah, and you will see now we have every single image correctly distributed. I just think this is really cool. So this is how we segmentate an image to. Oh my god, I wasn't sharing. Don't tell me that. Yeah, I wasn't sharing my screen, right? Oh my god. It was just my face. People, what you didn't tell me. Okay, don't worry, I'm going to explain all this again. Well, I just need to run the code. I mean, I already explained everything, but just if you lose it, this is where we extract every information of the row. Then we do the same for the columns. We extract we go row by row, extracting every information from the letters. And then when we have it, we just need to join everything together, and we slice um, from the original image the row from where it starts to where it ends, and the letter from where it starts to where it ends. This is what I was talking about, the sizes of the resulting images, standardize it to 26 to 26 pixels, and just I run the code, and we will see the output, A, B, come on, come on, come on, C, D, E, every letter of the alphabet. Interesting. Yep, that's all. Uh, this function, draw now, it's the one I'm using to make it an animation. Uh, so we can play this and go further and backward. That's what the draw now means. But yep, again, my face. Um, I hope you enjoy this session. I hope you can join us for the next one, because this little thing we do now, we are going to apply it, and with the information we are getting from this image, we are training a neural network, and then with that neural network well trained, we are going to predict. Well, it's not a prediction. We are going to interpret other images with the same font, uh, to extract text from images. So that will be, I guess, on January, because we don't have more sessions this month. But thanks for joining. I hope you enjoyed it. I hope you get excited, and see you in the next time, people. Bye bye.